Howdy. So we have to talk about a few things, and we will start off first with popping rocks in a microwave. It brought to my attention that some people are worried about my safety and the safety of the environment. So let's just have a look at this pebble here in the microwave, which is from this video. I will put a link below. You can go there and check it out. Now let's just have a look about. Of course, you can see here it's heating up beside or below the pebble. I put another pebble underneath the main pebble, so to say. And then it popped. Let's look at this again. Yeah, that's the whole thing. So what happened? The pebble popped. That's it. There was a little bit dust within the microwave. After the pebble popped, or we can see here, it's heating up. There's stuff going on. Molten silica is a very good conductor, so it's coming easier. After watching the camera that is pointing into the microwave because you can get a clear view. And after some time I go to watch from the other side. Yeah. Observing what's going on. So that's the whole thing that happened. The pebble popped and stuff heated up. What else would you expect in a microwave? As you can see, I wasn't too worried about that. I took my time and took some pictures. Took a closer look at that, and I figured that, yeah, it seems that the glass melted. You can see it sticks together. We have molten glass. And that's by far not the first time I have been melting glass within the microwave. Let's watch it popping pebble again. So, there are a few things I have to point out to the haters. First of all, that's the same microwave that has experienced many things. That's by far not the only pebble that popped in that microwave. No, I have been popping many pebbles in the microwave. And it's still working. And as you can see here in the background, the door, or however that's called, the lid of the microwave, which is glass, is still intact. It didn't open, nothing happened. The pebble popped within the microwave, and the microwave continues working. Nothing happened. Nothing even happened to the microwave. So, tell me what's the safety concern? Because this microwave oven has experienced some crazy things. And this little pebble that popped here is not the craziest thing. Some of the let's call them crazy because to many people that's crazy things this is going on, you know? It's dangerous. Yeah. Most often the scariest thing there is. Think about it. What's the scariest thing there is, in your opinion? I think the scariest thing there is the unknown. If you don't know something, yeah, it's scary. So, let me show you just one other thing. Electroboom, he's a very funny guy. I really like him. And he made this video some time ago. Can you microwave yourself? And the guy here in the background, Mr. Green, whatever, I don't know. That's just a part of a microwave. And here we have the magnetron. He puts a light bulb in his mouth, puts on the microwave, and the electromagnetic radiation makes the light bulb glow. And he makes some other things. He puts his head into a microwave. I won't show you now the video because I don't want to get any copyright stuff problems or anything like that. But I will put a link below to this video and check it out. Yeah, maybe you could call this crazy, but you also have to understand that like many people have microwaves at home and use them every day, and they don't seem to be concerned in any way. And also, it's said that don't put any metals into the microwave. There are like so many videos on the YouTube that you can go and check out when people are making experiments with microwave ovens. They are building stuff out of these. And I'm pretty sure that most of those people doing such things and put them on YouTube, they get money just by putting stuff on YouTube. There's like people making salads, putting them on YouTube, and they get money for that too. So my channel isn't monetized. I don't get money. Maybe one day. I have been thinking about this just for it would be somehow just fair. I don't know. Like there are so many people talking crap out there on YouTube and still getting money. And I really try to avoid using my voice for talking crap. So I really recommend you to check out this video from Electroboom and then make up your mind once again, as you have seen just before. Like, let's watch it again. Actually, here you can see where it starts to heat up. That's it. That's the whole thing. It shook a little bit the camera, but since the camera is on a thing that is attached to the microwave that shakes very easily, it doesn't take much in order for the camera to shake. And not the glass didn't break here, and there's also a glass in front of the camera that also didn't break. The only thing that broke is the pebble. And for those who are doing outdoor stuff, you can, if you are in the forest and you want to uh, fry a fish or whatever on the fire and you don't have a pan with you, you just search for a stone that is flat, you put it into the fire and it heats up and you can cook your food on a stone. But never ever take a stone that has been in the water. Try to find as dry stones as possible because if they heat up too fast and they have water inside, they might pop like this stone here. And you can see here the actual stone, it has this layering. I was rather much expecting this stone to pop. Yes, because I'm in many microwave experiments. Those which are visible on my YouTube channel are just a small fraction of my experiments. Many of the experiments, there is no footage at all. And there are many experiments. I took footage and it, like after 10 minutes, I just stopped the experiment because nothing happened. So there's no point showing you an experiment. You're just watching 10 minutes a pebble in the microwave, which doesn't do anything. Maybe after half an hour it would do something, but that's a too long time span for my patience. And I don't know. It doesn't make any sense. Some of them just warm up over time. That's it. And after 10 minutes or something, you still can keep them in your hands, and that's it. And there are other experiments that are rather interesting. The results are very interesting. As you can see here, that's the result of one of the microwave experiments. That's from the same video. Dancing pebbles, molten glass, popping rocks. Yeah. Here you can see fault lines, as geologists are calling them, fracture zones and stuff like this. Yeah. Because Earth is growing. And let's go back to the popping pebble. Where is it? I actually managed to capture the exact moment today when it burst. Let's try if I can make it. Yeah, there's probably within the rock something molten and here flying around something, and that's basically dust. Yeah. So what happened to the environment? Nothing. Yeah, because the environment is basically the microwave. Yeah, every now and then, pebbles, they start, yeah, I can smell the sulfur because I have shown you many times having burning sulfur within the microwave. Maybe the sulfur emissions from a microwave experiment is maybe 1.5 grams, or maybe even less of sulfur dioxide. Yeah, that's not that much compared to whatever volcano on Earth that emits thousands of tons of sulfur dioxide, or copper refining factories, or whatever else things. So there is no environmental danger. And again, this microwave has experienced already so many things, and the glass door is still intact. And for those who don't know why we have this metal mesh here in the door, it's just that the microwaves, which are approximately 12.4 centimeters in length, that they don't reach the other side. And the whole microwave inside is made out of metal. And here on top you can see the heating, whatever they are called in English, because this microwave has a grill function which you don't need whilst making the microwave experiments. But the grill function itself just makes the microwave much more heat resistant. Okay, so now, why is it important to understand this pebble popping in the microwave? Because there is some hype going on at the moment all over the place. But let me first show you something else about what you should do with a microwave and what you can't. That's some Finnish mainstream news stuff here. Obviously, it's Finnish. Some, let's say, famous guy from Finland. He was putting a metal spoon into the microwave. Yeah. Electroboom did that too. And what happened? Nothing. The spoon got warm after a while, but that's it. So, and here, later on, if you scroll down a little bit, on new microwaves, they tell you if you want to warm up water for your tea or coffee or whatever, don't put an empty glass or just water into the microwave. Put a spoon in there. A metal spoon into the glass of the water because it heats up much faster. In some microwaves, or nowadays you find a batch that recommends putting a metal spoon into the microwave. Right? Yeah. That's amazing. You know? How old is that? 2023. Check it out. It would be interesting to figure out if that guy watched one of my videos. I don't know. But anyway, this pebble that popped. Latest NASA observations make asteroid 2024 YR4 the most dangerous since tracking began. Everybody's freaking out about this asteroid at the moment. The chances of asteroid 2024 YR4 colliding with Earth in 2032 have risen again, making it the most dangerous near-Earth object, NEO, since astronomers began tracking them. So, there would be so much to talk about planetary bodies approaching each other, because over longer distance they might be attracting each other, but as they get closer, they might start to repel each other. And if they get too close enough, or too close to each other, there might happen electrical discharges because nature seeks for equilibrium. And this ties into Velikovsky, how he was one of the first that brought electromagnetism into cosmology and mythology and all these other things. So, everybody's freaking out about this one asteroid, 2024 YR, is an asteroid that is classified as an Apollo-type Earth-crossing near-Earth object with an estimated diameter of 40 to 90 meters. All right. The Chelyabinsk meteor, many of you hopefully remember, a wake-up call for Earth. The Chelyabinsk meteor was a small asteroid about the size of a 6-story building. Yeah. So it was approximately the half of where we have it. 40 to 90 meters is the 2024 YR. And the Chelyabinsk meteor was approximately 18 meters. So it's about the half of this one. Okay. But anyway, Chelyabinsk meteor. The blast was stronger than a nuclear explosion, triggering detections from monitoring stations as far away as Antarctica. The shock wave it generated shattered glass and injured about 1,200 people. The shock wave it generated. Why? Because it broke up in the atmosphere, but we will come to this in a bit. The incident was another reminder to space agencies about the importance of monitoring small bodies in space that could pose a threat to Earth. Yeah, maybe politics is a bigger threat to Earth. Yeah, I won't say any more about this now. Anyway, the same day Chelyabinsk happened, the US House of Representatives Science, Space and Technology Committee said it would hold a hearing to discuss asteroid threats to Earth and how to mitigate them as an addition to NASA's current efforts. Coincidentally, the explosion came on the same day that an asteroid was flying by Earth, called 2012 DA14. It passed within 17,200 miles, 27,000 kilometers of Earth. NASA quickly pointed out that the asteroid was traveling in a direction that was opposite to that of the small body that exploded over Chelyabinsk. Yeah, so they were watching at the wrong direction, and everybody was surprised. All right, so you can ask yourself what's how accurate or how reliable they are, because they were watching all together this one asteroid flying somewhere, and all of a sudden we had Chelyabinsk, the meteor, which is here. Can we get this big? Yeah. This is the Chelyabinsk meteor. It got brightened and then it broke out, or broke off, or up. Hmm. Because Earth has many atmospheric layers. The envelope of gas surrounding the Earth changes from the ground up. Yeah, it does so also when you come from the outside. 5 distinct layers have been identified using thermal characteristics, chemical composition, movement, and density. Each of the layers are bounded by pauses. Hmm. Where the greatest changes occur in thermal characteristics, chemical compositions, movement, and density occur. Here we have the thermal pause. This is exosphere. This is the outer layer of the Earth. It extends about 375 miles, blah, blah, blah. Thermosphere, mesopause, stratopause, and here we can see it again. Let's make it a bit bigger. Mesopause, stratopause, tropopause. All right. I think Earth's weather is entirely electric in nature. Therefore, like also the reason not only that Earth or other planets have an atmosphere, the sun has an atmosphere too, is that there's a Birkeland current running through the center or the core of Earth and the other planets. And there might be this kind of a plasmoid at the center. Moons maybe don't have a plasmoid at the center, but the planets and stars, some of the stars are plasmoids, but the planets, they have the plasmoid at the center. And because there's a current running through the planets and the Earth and stuff like that, it will create these layers, and each of them is a plasma double layer. These are the layers of the atmospheres that are called here Mesopause. They are pauses. Pause. Doesn't make any sense to me. It is rather confusing. But try to remember this curve that goes in a way in a zigzag kind of manner. Here we have a pause, then it goes into this direction. You have another pause, and it goes into the other direction. We have another pause, and it goes in the other direction. Right? We are here at plasmauniverse.com. Double layer classification. Weak and strong double layers. You can see double layers. Here's a diagram. And here we have the same zigzag kind of feature. Here we would have what NASA or NOAA or whoever, what are they? NOAA. Yeah, NOAA is calling them pause. That's a double layer, and they are calling them pause. That's the same zigzag thing. It changes direction at the layer, at the interface. Zigzag, a double layer, direction of change, double layer, direction of change, double layer, direction of change. It goes into this direction, double layer, change of direction. So this would just continue, and of course it would be 90 degrees turn in order, but you get the idea. But nonetheless, these are double layers within our atmosphere. And if anyone can explain to me how gravity could do such a thing, I would really be interested and keen to know what's the thing about that. And of course, here we can see like 160, 140, 20 kilometers, the auroras. And the heights of these layers and the size of the actual layers, they change over time. Okay? So if there is a solar impact, a strong CME or something, they get squeezed together. But that would be the theme of another video or topic. Like there could be so much talked about these. But anyway, so we have these different layers, and there are different energetic potentials within these layers, and especially these layers, I think they also different in thickness, so to say. That's where satellites and stuff burn up, like Musk's satellites and others. They burn, they get really hot as they enter certain atmospheric layers or go through certain double layers. Stratospheric double layer would be probably a much better name than stratopause. Tropopause. It's not a pause. There's nothing pausing there. It's a double layer. Because take it to the max, the ionosphere. The ionosphere. Yeah, there's plasma. Because only you get like plasma only with electricity. Wherever you find plasma, and there's a lot of plasma, wherever you look within our bodies and stuff, it's electric in nature. So, as an asteroid flies into the Earth's atmosphere, depends, of course, on the angle, but it will experience rapid heating at one point of the atmosphere. There will be strong induced currents into the bolide that comes into the atmosphere of Earth, and this is going to happen. It starts to glow and eventually will break up. That's the same thing. That's an asteroid entering Earth's atmosphere. It starts to glow and it breaks up. So not only can you create a pocket-sized volcano in your microwave, but you can also replicate basically an asteroid or meteorite entering Earth's atmosphere. It heats up basically too quickly due to induced currents and it breaks up. Yeah, that's the point. Popping rocks in the microwave are basically meteorites or asteroids entering Earth's atmosphere, and they experience similar fate. They pop. Of course, it depends on the constituency of the meteorite or asteroid or however you want to call them. What they are going to do. Composition and structure of the Chelyabinsk meteorite. Yeah, that's a scientific paper. I try to provide a link to this. Now let's go to this one. Composition and structure of the Chelyabinsk meteorite. I found very interesting. Of course, I'm interested into aluminium. Yes, that's very interesting. I like aluminium because it's one of the most abundant elements in Earth's crust besides silica. But anyway, here, like there are different kinds of samples. Sample number 2, just 0.01. I don't know if it's that weight percent. Yeah, that's very little aluminium. But then the sample or analysis number, then we have already more than 20, 21.7% of aluminium. And the interesting thing is that here, where we have a lot of iron, there's very little of aluminium. And where we have a lot of aluminium is very little of iron. I don't know why yet. Maybe I'll never know. But I think that's something important to point out. Where we have a lot of iron, there's very little aluminium, and vice versa. And one of my microwave pebbles, or maybe even in both, there's also titanium oxide has been found. Basically, not officially, but I have proof for that. Basically, you can go to check it out. You will find it if you want to. So, there is also aluminium within the Chelyabinsk meteorite. Now we have been talking about popping microwave pebbles, about the danger potential of making microwave experiments. Like if you have molten glass in your microwave and you touch it with your bare hands and you get hurt, it's not the microwave's fault. Okay. I've never experienced any injury or whatsoever because you can use gloves, you can use tools in order not to get hurt. And the thing is also like if you notice that there is something going on in the microwave that maybe is a bit sketchy, you switch it off and it will stop immediately. As soon as the induced energy from the microwave ends, the action will almost stop immediately. And if you experience some plasma going on in the microwave while the microwave oven is on, just don't pour water on it or whatsoever. You know, not a good idea. But you can put water into the microwave as we just seen. Maybe you have done it by yourself. Like if you put a glass of water into the microwave. Yeah, the glass is made of silica. Yeah, silica. And here, what is glowing here at the bottom is molten silica, molten glass within the microwave, right? So it wouldn't be a good idea just like open the door and throw some water inside because it's not good. But it wouldn't be the microwave oven's fault or whatsoever. It would be the user's fault. Just don't. Give it time to cool down. And if you're not sure what you are doing, probably just don't do it. Maybe you have to read up a few things before trying stuff like that. But anyway, there is still something else I wanted to talk about because here on this site, the Pulse EPMC Diffusion Research, you can find some of my papers. Here are two papers that are peer-reviewed and published. I am working on this here to get it published. I don't know if I can manage. Actually, here I'm talking about the microwave stones. Yeah, it doesn't load here now, but anyway, here in this issue, we have the mountain water paper. A new approach to mountain forming, volcanism, glaciers, and the role of water in an electric environment. Yeah. Now we have to scroll down quite a bit. I will put a link. You can find this on the page. So here we have the mountain water paper. People settle near water. Almost all life forms need water. Water is very important for life on Earth. Textbooks and geoscientists may be wrong about how the Alps were formed. So I'm basically talking quite a bit about the Alps, but in another sense, this can be applied to many, many, many mountains or volcanism in general, maybe to all mountains almost. Yeah, can't be flick, It's in the news nowadays. I've been talking about Campi Flick recently. I've been talking about Mount St. Helens a few times here. Here is about like my vision theory, or however you want to call it, about Earth's core being a plasmoid, about the layers of the atmosphere and stuff like that. But we go like here, I'm pointing out about this lake that has been making floods, or like it was associated to the floods that happened in Brick. Like here we can see the cars smashed into the walls by the flood and stuff. The Saltina was blamed for the floods. The name Saltina comes from the Latin word saltare, to jump, and has records of flooding as early as the 14th century. Hmm. We have to assume the stream's name is no coincidence and can be seen as a warning from the ancient people. We have, like earlier mentioned, many hints were there in plain sight all the time. Many just have been overlooked or they aren't taken serious anymore because for a long time nothing happened. The knowledge died out. A huge amount of water poured out of it in a very short amount of time. The water was quite likely perfectly drinkable in quality. This possibility should be taken into consideration. This is an assumption based on the absence of news about the water being poisonous. As much as the water which drops from the sky has different speeds according to the strength of the discharge, lightning may also reach upwards from the ground towards the heavens. Yeah, positive lightning. Possibly, a weather system with enough electromagnetic potential could trigger an eruption from a sleeping cold water geyser, i.e., a cryptogeyser. Geyser. Yeah, in my last video, I have been talking about this Borealis mud volcano in the Arctic Ocean that erupts warm water, 11.5 degrees Celsius. Yeah, I would consider this as cold water. So, conclusion. Possibly, glacier carrying mountains and mountains with craters on top which are fed with groundwater, hence lakes, should be called cryptogeysers because they are active geological features. They should be treated with respect because they can be very dangerous. Millions of people live within the Alps region, many probably totally unaware of the danger potential of their environment. While glaciers are considered as contemporary lava streams made of water, which means it is part of a volcano, which do erupt with water, each according to its own frequency. This explains glaciers in a totally different context from the commonly accepted science. By the way, Grímsvötn volcano in Iceland is one of Europe's biggest volcanoes and it is buried under Europe's biggest glacier. This is maybe not so much of a coincidence after all. Yeah, thank you, Bruce Layburn, for helping me. Layborn, maybe. So, let's quickly hop over to Mount Spurr. Maybe we go here first. Let's see if I can find it here on the map. Mount Spurr. Yeah, it's somewhere here. Maybe it's not findable here. Let's zoom out quickly. Yeah. Anchorage is here, so we have to go to the left. Maybe it's this one. Where's Anchorage? Anchorage? Chakamuka? Anyway, there is some seismic swarm going on at Mount Spurr. So I have been googling Google Earthing around there for a bit. And that's one picture I found very interesting. Because according to common science, basic science, mainstream science, or however you want to call it, glaciers are formed by snowfall accumulating, and due to gravity, they are going downhill. Yeah, there's no snow here, no snow here, but still we have a glacier here in the middle. So that's the Mount Spurr region. There are several features. For some reason, we have rather patchy imagery here. Most of it is rather blurred out for some reason. So this is one of the enclaves or where the glacier basically ends. And there are other interesting features down here. This doesn't seem to be ice. Maybe it is, I don't know. Seems to be more sedimentary in nature. And there's another one here, or maybe even two. And water stream is flowing there. Maybe I have to zoom out just a little bit. Yeah, that's the glacier. That's one of the glaciers. All right? It really does look like a glacier. And I have made many videos about this topic. 450 or 350, I don't know. But since this is an actual, there's talk about this. Now let's just follow this glacier uphill. Yeah, Mount Spurr. And it starts on top of the mountain. And as we go here on top of the mountain, you can't see anything. It's all blurred out. And it's very hard to me to believe that that's a coincidence. Yeah, there's something that they don't want us to see. That's the glacier. And it's flowing downhill straight from the volcano. And as I said in one of my previous videos, Earth is the water planet. So we somehow should maybe assume that the material that is erupting from beneath our feet, the most common material erupting from the ground, is water. And as I've been describing in my mountain water paper, mm, like every water spring, or the example from the somewhat recent few months ago, glacier eruption in Yellowstone that made people run for cover because the geysers, usually there's just water coming out. But all of a sudden there was also mud and rocks coming out. Yeah, that's the same thing. Here's a good example. Here we have the ice, which is officially to the International Mineralogy Association. Ice is a mineral, basically like all other minerals too. Here we have the ice, and there's the mud. Yeah, there is some. I'm not saying that snowfall doesn't have anything to do with glaciers. Yeah, because there's snowfall often where we have glaciers. But here is a glacier, I guess. Here is one. And basically the same pattern continues. And here we have the mud flows. And also, as you would expect, and as I have to try to explain many times, if the water there at these kind of places would be meteoric in origin, like rain, snow, hail, what have you, it would be just water. It would be the same color, but here we have several different kinds of water bodies, and almost each of them has a different color. Okay, that's somehow beige, light brown, greenish. Maybe that's even a bit frozen. No, that's a nice example here. 4 water bodies and each of them has a different color. To me, this is a very obvious sign that the water in these is at least partially coming from below and not from above. Yeah, there might be also a reason for why they have these kind of shapes. You know? Yeah. Here is another example. The ice and the mud flow. Barrier glacier. Yeah. And here we have a mud flow where there is no ice on top. So if glaciers would be entirely made by snowfall, then we would expect this being covered with snow as well, because they seem to be side by side, right? Side by side. So this picture is taken at the same time. Ice, no ice. Or are you trying to explain to me? Yeah, it was snowing here, but here it wasn't. Really? It doesn't make too much sense to me. So glaciers are lava streams made of water. Thanks.